Okay, so if these two problems are causing you a headache, that's kind of good because they're supposed to make you think. We'll take everything we've already done up until this point and kind of put together. And it's in the form of a word problem, which we know everybody hates. So let's take a look at 14 first and just take time to draw it out just like all these other circuits we've been solving. So we've got a power source, DC generator. We got a amount of current that we're putting out. We have a bank of lamps. So resistor. And we have a resistance for the wire. So let's say these are the lamps. Your DC generator's over here putting out 120 volts. So we'll call this R2, R1. Now R1, we know a resistance value on it, right? 1.05 ohms. And the lamps, they said that they had 50 amps. So we could fill out our little chart, see what we can solve for and what we can't. So we have a voltage total, 120 volts. We have R2, a current of 50 amps. And then we have a resistance value of 1.05 for R1. 1.05 ohms. Now, just based on what we know about series circuits here, you know the current is consistent, right? And what value are we solving for here? It says, what is the total voltage drop from the generator to the first bank of lamps? So from here to here. Well, the only thing we have in there is a resistance value of the wire. So we're looking for the voltage drop of resistor 1. So right here we're solving for the voltage drop. So we're solving for this value right here. And we have enough information to solve for that, right? E equals IR. So your E1 is going to be equal to I1 R1. So E1 is 50 amps times 1.05 ohms. So I'll put that in. 50 times 1.05. And that gives you a voltage drop of 52.5 volts. It's a pretty big voltage drop for some wire. But we had enough information to get that, right? Because we had the current, we had the resistance. So that's really all we had to plug in there. So 52.5 volts. All right, let's take a look at the next one. So down here, we have a 7 horsepower motor supplied from a 240 volt DC power source. There's a 120 watt heat loss in the motor leads, 350 watt loss at the lines supplying the motor. So based on what they just said, I know I have a 240 volt DC power source. I have lines with a resistance value that we don't know yet, supplying some leads when it goes into the pecker head of the motor, and then the actual motor itself. So the motor we know is 7 horsepower. We'll take a look what we can do with that here in a minute. The lines supplying the motor, let's see, the 350 watt heat loss, the line supplying the motor. So we got 350 watt heat loss here, and then 120 watt loss here. That's the leads. So we got lines, leads, and motor. So we'll call this R1, R2, R3. We have to add a category here because we need to find the power. We may not need to solve for all of these. We'll make some boxes. Okay. So if we have 7 horsepower, that doesn't do a whole lot for us because we have wattages for the rest, but we have the conversion formula, right? So times 746 is going to give us 5,222 watts. So now we have the wattage at every single resistor. So we got at R1, R2, R3, we got 350, 120, and 5,222. So 350 plus 120 plus 522, 5222 is 5,692. And then we have our voltage total here too, right? So probably the easiest thing to solve for would be the current here. And to do that, we're just going to take, based on our Ohm's law, I equals P divided by E, to take 5,692 divided by 240. And let me write a little room in there. That's going to give us 23.717 amps. And what we're looking for here is the voltage drop across the motor leads, right? So at the 120 watts, we're going to find out what the voltage drop there is. And that was our R2. So we're looking to find this value here, right? So we don't need to solve the entire thing. We just know that we have current now, and based on a series circuit, we know that's going to be the same here. So now we have the wattage and the current, and we're looking for a voltage drop. So again, it's going to be the similar formula here, but instead it's going to be E equals P over I. So let's go ahead and plug those in. So we got 120 watts divided by 23.717. That's going to give us our voltage drop there. And that gives you what, 5.060 volts. So the voltage drop across the leads only is 5.060 volts. All right, so we got our voltage drops in both those categories. Give me a call if you got any questions.